Hello everybody, this is Dr. Bruce. Welcome to my tutorial for crime analysis students series. This is video number 5 on quantitative crime analysis techniques. It's going to be a long one, I apologize for that, but you don't have to watch it all at once. There are some clear, good stopping points along the way, but by the end of it you ought to be able to do the most common quantitative analytical techniques in crime analysis, including calculating measures of central tendency, applying rates, figuring out correlations, and doing basic linear regression. If you have not already watched video number 4, I guess, where I go through aggregation and filtering with large data sets, I encourage you to do that first if you don't already have those skills, because those are skills that are important on the way to preparing the data for the types of calculations that we are going to do here. Now, quantitative analysis comes up all the time in crime analysis. Both quantitative analysis and qualitative analysis are, of course, important in almost all crime analysis areas, but quantitative, really just steps forward in what most people think about when they're looking for something from a crime analyst. They're usually looking for some output from a data set, a structured data set, and that's almost always going to involve quantitative techniques. The most obvious, of course, is in the calculation of crime statistics. And in my video number 2 of this series, you learned how crime statistics are aggregated at the national level for national crime reporting, but this is an example of a statistical sheet from a single police department. This is the Chicago Police Department's ComStat figures at the end of 2024, and notice how the crimes that they track are defined essentially by the old Part 1 crime list from the Uniform Crime Reporting Program. I said during that video that that's often the case, that agencies, even small agencies that hardly ever have any homicides, will have monthly reports that show murder as the top category, 0, 0, 0 filled in for every time period, just because they're so used to reporting in terms of those 8 index crimes. So there's a couple, small changes to terminology. They use criminal sexual assault instead of rape, and aggravated battery instead of aggravated assault, but otherwise this is pretty much the same, except for the shooting category down at the bottom, which of course shootings can be murders, they can be attempted murders or aggravated batteries, they could be I don't know what they're including in there. They could be robberies. They could be somebody shot at you and missed, or just a shot was fired. I don't know if they're including those in that list, in that category. But in any event, that's a category that they've created on their own because they're trying to track that particular thing. The more important part is the statistics that we're looking at here. So for the last 7 days and the last 28 days, we see the percentage change from 2023 to 2024. That's a very common quantitative calculation, looking at the percentage change from one time period to the next. But a crime analysis product doesn't have to be full of numbers like this in order for it to be a quantitative product. Here, take a look at the Frederick Police Department's pattern bulletin on liquor store burglaries, in which there aren't a lot of numbers present here in this bulletin, but the analyst clearly behind the scenes worked with numbers and came up with a date range and a time range that she wanted to highlight here, basically suggesting that this is the time that officers need to be on particularly alert patrol in the areas that have liquor stores. Now, I don't know what specific calculations she did to come up with that list of dates and that list of times, but it probably used some measures of central tendency and variance. So very often the output of quantitative analysis is just something simple like this, where a lot of math might have gone on behind the scenes. Then there's a whole area of quantitative analysis called spatial statistics, where we work with spatial variables like coordinates and distances and directions in order to identify, say, the mean center of a crime pattern, or what what areas are top hotspots, or where an offender might be most likely to live based on the pattern of where his crimes have been committed. Again, the math that was done is not shown in these products, but that doesn't mean that it wasn't done. That doesn't mean there wasn't a lot of math behind the scenes, and that's the essence of what quantitative analysis is about. Now, before we move forward, let's take a look at the differences between quantitative and qualitative analysis. Both, again, are very important in crime analysis. I like to say that without qualitative analysis, quantitative analysis is just a lot of numbers without any context. And without quantitative analysis is just a bunch of stories without any meaning, without any proof. An anecdote, a story that somebody tells you, is just qualitative data, but if you stack it up with a bunch of other similar anecdotes, if you structure them and then you're able to count the number of times that a particular thing appears within them, you've turned that into quantitative analysis. And it's very common to go back and forth like that between the two types of analysis in any analysis or research project. The distinction is made largely because there are people that are good at one or the other. If you're more left-brained, you tend to be good at quantitative analysis, and if you're more right-brained, you tend to be good at qualitative analysis. And I go to a lot of more academic conferences where the two types of researchers are present, and it's funny to watch them interact. They both would admit, if you really press them, I think that, yes, both types of analysis are needed, but that doesn't change the fact that the quantitative researchers tend to look at the qualitative researchers like a bunch of hippies who want to always talk about feelings and sit around in talking circles and so forth. And the qualitative researchers think the quantitative researchers are a bunch of robots and who are cold and emotionless and only care if they can prove what they're talking about to a particular p-value. So it's just funny to see those stereotypes in play, even though, as I say, everybody would recognize if you really press them that you need both. In at least social science, I suppose there are some hard sciences where quantitative analysis is really the only thing you need, and there are some arts in which qualitative research is really all that you need. A biography, for instance, of a person, a famous person, is entirely qualitative. You don't need a bunch of tables that add up all of the the things that they did or the number of times they were in particular places, right? You're not trying to prove anything with numbers when you read a biography. You're just interested in the story. So that would be purely qualitative. But crime definitely needs a mix of the two. So with quantitative analysis, we're working with structured data, discrete fields, things that we can subject to different levels of measurement. With qualitative analysis, we're working with unstructured data, narratives, texts, images, videos, audio recordings, and so forth. With quantitative analysis, we are using tools like central tendency, trends, relationships between variables. With qualitative analysis, we are trying to identify common themes among stories, among, again, images, trying to understand a phenomenon. In quantitative analysis, we use what's called a structured research design. We know going into it what questions we're going to ask and how we're going to ask them and what we're going to regard in the end of the process, at least in formal research, as proof. With qualitative analysis, very often you start something and then you change the design as the project goes along because you learn new things from your initial investigations. When you're doing, for instance, interviews with offenders, a famous qualitative analysis project was with Robert Ressler and John Douglas from the FBI, interviewed serial killers throughout the United States in the 1980s in order to build sort of a knowledge base of serial killers and how they behaved and what their motivations were and so forth. They didn't know what questions to ask when they first started doing it. And as they interviewed more and more serial killers, they started to learn the types of things they ought to look for, and then were able to change their approach to those interviews based on those early lessons. So that's what I mean by an emergent design. Quantitative analysis ideally uses random sampling so that you can generalize the results, if you have to sample, so you can generalize the results to a larger population. Qualitative analysis specifically seeks out individuals or places or a population of data to study because it matches certain criteria. Quantitative analysis often verifies theories. Qualitative analysis often helps develop those theories. And the primary contributions of quantitative analysis are facts and proof, whereas qualitative analysis provides meaning and context. All right. With those principles in mind, we're going to jump into a series of lessons using an Excel workbook where we do the most common calculations in crime analysis when it comes to quantitative analysis. So we're going to look at central tendency and variance, change, rates, correlations, and simple linear regression. If you're taking a class with me, and that's why you're watching this video, you should have received a copy of that workbook in the class that you can follow along with. If you're watching this on YouTube and you're not in a class with me currently, I will post a link to the workbook in the YouTube description for the video, so you can download it from there if you want to follow along. You're also free to follow along with your own data sets and try to apply it. Watch me do it with the sample data and then apply it with to your own data. There is one more important theoretical or bit of terminology that I want to cover, though, before we get into the physical calculations, and that is the levels of measurement. The concept of levels of measurement is very important when you start to get into quantitative analysis. Consider, for instance, the Kansas City Police crime data set that I used in a couple videos ago when we did filtering and aggregation. This spreadsheet has a variety of different data fields, and each one is subjected to a different level of measurement that defines essentially what we can do with the data. So the first level of measurement is categorical or nominal level, which is used for things like names, sex, crime types. Somebody might argue with me on crime types and want to make that ordinal, but we'll talk about that. But basically, they're text, right? They're not numbers. Numbers assigned to those things wouldn't mean anything, right? You could assign 1 to male, 2 to female, but they wouldn't make any sense. They wouldn't have any order, right? There is no order to sex. There's no order to race. There's no order to somebody's name. There's alphabetical order, but that there's no real meaning to that. That's just a construct of how we design the alphabet. You can't put categorical or nominal data in any sort of particular order from less to more or least to most or anything like that. The way that you can with the other data sets. So that means there's very limited amounts you can do with categorical or nominal data. You can count it, you can establish frequency distributions, you can test whether one is equal to the other, you can do percentages of those frequencies and so forth, but that's just about it. Ordinal data is data that is like categorical data. It doesn't really have numbers that have equal values in between the different steps, but you can put them in order at least. So an educational degree is one. Do you have an educational degree with choices from like, no high school diploma, bachelor's degree, master's degree, doctorate degree, and so forth? There isn't an equal level between those categories, right? In order to get a high school diploma, you had to go through 12 years of schooling. Then you had to go to 4 to get a bachelor's degree, then maybe 2 for a master's degree, and then maybe 7 for a doctorate degree. So you can't say that from moving from one category to the next has an equal interval between them, the way you can with interval data, the next category. So although you can put them in order, you can't assign numbers to them and then calculate averages, for instance. And so for that reason, again, there's limited quantitative methods that we can apply to ordinal data. We can put them in order. We can find the median. We can find the halfway point, and but we can't really do any serious calculations. Again, some people would say the crime type should be ordinal. Like murder is obviously the most serious crime, and maybe something like trespassing is the least serious. But there's a lot of obviously qualitative decision making that goes into that, right? Is a shoplifting more serious than a theft from a vehicle? So the FBI's NIBR's codes from murder at 09A down to all other offenses at 90Z are supposed to be in kind of an order of seriousness, but I think it's debatable. The specific damage a crime does, it has to be figured out individually for particular victims and the dollar value and the amount of injury inflicted and so forth. And so I wouldn't think of the crime type as an ordinal crime. But, misdemeanor, felony, petty offense, that the crime level, that definitely is ordinal data. Class A, Class B, Class C, Class D, Class E felony, in terms of what's punishable by law, is ordinal data. The interval data is actual numbers, and therefore they can be not only ordered, but you can calculate the mean, you can calculate the variance, you can do correlations, you can calculate trends, regression analysis, and so forth. Interval and ratio data are often described as part of the same category because you can essentially do the same calculations with both of them. The difference between them is very slight, but it's still important to have in mind, and it's an important part of the theory of what we're doing here. Ratio data has, with ratio data, the number 0 has meaning as an absence of it, right? As there are none of this particular thing. So, with age, for instance, to be an age of 0 means you're not born yet, or you're just, you just have been born. A dollar value stolen. Somebody broke into my house. What was the dollar value that he stole? $0. He didn't steal anything, right? 0 has an actual meaning there. And not only does it have a meaning, the meaning means an absence of that variable. Whereas with some interval data, like the hour of the day, what does 0 mean? Well, it means midnight. It doesn't mean there's no time, right? It just means that's just where our particular system of timekeeping happens to break off and to start over every day. So, you can't really average times the same way that you can ratio, like ages. Because if one crime happened at 2200 and the other happened at 0200, what's the average time? Well, it's actually 2 plus 22 is 24 divided by 2 is 12. It's noon is the average time between 10 p.m. and 2 a.m. When of course we would, looking at it logically, think no, midnight should be the average time between those two. But you can't do the sort of calculations on time because it's cyclical, and 0 it doesn't mean nothing. 0 doesn't mean nothing for the date either, right? I mean, I guess if we go back far enough, it does. But our particular system of date keeping goes into the negatives once we hit the year 0. It doesn't mean there was no date. It doesn't mean that life didn't exist at the year 0. It's just an arbitrary point. Temperature. On the Kelvin scale, sure, 0 means an complete absence of temperature. But a temperature of 0 on other scales just means it's really, really cold. And for that reason, you can't say, for instance, that 10 degrees or 20 degrees is twice as hot as 10 degrees. That's pretty meaningless. So ratio data is numbers where 0 actually means the absence of something, and because of that, you can calculate rates and ratios with ratio data. So going back to our Kansas City data sheet, we see we have lots of nominal data, the offense, the address. The street number part of the address is ratio data, I suppose, but there isn't a lot of, at least in most places. There are some places, I suppose, where it jumps around, but it's not really, is it? Because when you go to real cities, if you're at 20 Main Street, that doesn't necessarily mean you're exactly the same. It doesn't mean that your distance from the beginning of Main Street is exactly half that of 40 Main Street, right? So houses are given numbers in order, but those numbers don't necessarily mean what actual numbers would mean. Some grid cities, they do approximate that, but you have to be careful. Sometimes the numbers are assigned to things. Beats are another example, right? There are numbers assigned to that, but that doesn't mean it's ratio data, because they're just labels. They don't actually really mean anything. Beat 0 doesn't mean an absence of the beat, but even beyond that, you can't even you can put them in order, and maybe they would go geographically in some order across the town, but they're really just labels. So just because something looks like a number doesn't mean it actually is. A beat here is really nominal data. So is the IBR code, I think, for the offenses. Zip codes, those are just, even though they're numbers, they're just nominal data. So lots of nominal data, lots of categorical data on here. Then you have ordinal data. I think the address number would be a good example of ordinal data, at least. What else? Really isn't much else for ordinal data, is there? We got a true or false field, a domestic violence flag. That's a nominal data set that's also binary, meaning there's only two values that can go into it. Then we have lots of interval data, dates, times. And then for ratio data, we really, in this particular data set, only have the coordinates. Okay. Oh, actually, I'm sorry. The coordinates are an example of interval data, aren't they? They're not ratio data, because ratio data would mean that 0 is, there's just nothing there. But obviously, the 0 point for coordinates is an arbitrary origin point. 0, 0 is off the coast of Ghana in west of Africa. It doesn't mean that there's no space there. So there really isn't any ratio data at all in this particular data set. But here's the thing. When we aggregate data, then we create other types of data. So for instance, offenses are just nominal data, right? But if I turn this into a pivot table, and actually I'm going to count the description. So one of the only things you can do with nominal data is to count it. But that count is ratio data. The count is ratio data. So I can do stuff with this. I can, it won't be very meaningful, but I can say that, I can sum it. I can say there were 61,809 total offenses. That's over here. I could average it. I can say that for the average offense, again, it's not terribly meaningful, but for the average offense, there were 1,166. More importantly, I can do ratios. I can say there were 3 times as many prostitution offenses as there were bribery offenses, right? So the process of aggregation also often creates new levels of data that we then can do some of those other calculations with. But what I can't tell you, what is the average crime committed in Kansas City? How do you determine that? How would you determine just the average crime from a list of crimes? Well, you could use the mode, I suppose. You could say the average crime is motor vehicle theft, because that's the most common, right? But usually when people are talking about average, they're talking about median or mean, which can't be done with nominal data. All right, I think we get the point there. So let's get into our spreadsheet and start working. The quantitative analysis sheet has a number of tabs down at the bottom that we're going to be going through. And I'm going to go through these calculations relatively quickly on the assumption that you can watch this multiple times. You also have the option to slow it down. You'll hear me talking in a very slow voice, but that'll be fine. Just if it helps you pay attention to what's happening with each of the calculations. So the first thing that I want to cover here, using the UCR statistics for 2024, as I record this video, these have just been recently published. Again, my video number 2 tells you how we get these statistics for the nation in the first place. So these are the data you can download from the FBI is still in the old summary reporting system format, meaning the hierarchy rule is employed, and we really only have the 8 index offenses. But with these, we can determine something like which cities in this country have the highest crime rate. So the first thing we're going to calculate is rates. Now, before we begin, I'm going to freeze my panes at cell C2 here, so I'm always going to see, when I scroll, I'll always see the city and state, and I'll always see the top row here. So you always click below and to the right of where you want to freeze, and then go to the View menu and freeze panes. And that way, as I scroll down, I won't lose my first row, and as I scroll to the right, not that I have to on this sheet just yet, but I won't lose my city and state. Okay, so we have the violent crime total here is a addition of these 4 fields: murder, rape, robbery, and aggravated assault. It isn't a separate category. Similarly, burglary, property rather, is a addition of burglary, theft, and auto theft. Arson doesn't appear in either of the 2 counts. And it's a bit of an odd one out, arson, because there are a lot of agencies that don't report it because their fire departments are the ones that make arson determinations, and not the police department. So the FBI doesn't get those statistics. So a lot of the time we simply work with the first 7 of the index crimes. But in any event, we want to calculate our rates, right? Because it's easy enough to sort this by total. What city had the highest murder total in the country? Well, Chicago did, at 461 murders. Does that mean Chicago is the most dangerous city in the country? Well, not necessarily. It has a population of 2.6 million people. Now, if there was another city out there with half the population that had 300 murders, that would have a higher murder rate, right? There would be more murders per the number of people they have, and thus it would be a more dangerous city. Although right away we see that New York City, at 8 million people, had fewer murders than Chicago at 3 million. So it's safer both in terms of total volume, but also in terms of rate. New York is going to come out looking relatively good when we do these calculations, because as the most populous city in the country, it obviously is going to have some high crime volume. That doesn't necessarily mean that it has a high crime rate. So over here in column N, I'm going to type murder rate. And I'm going to calculate how the murder rate based on the population of each city. And it's a very simple calculation. We take the murder total, E2, and divide by, let me zoom in a bit here. We take E2 and divide by the population, which is C2. And we get a very, very, very small decimal number. That is the number of murders per person in Chicago in 2024. Now, obviously, that number is going to be a tiny decimal number. If it was like 1, that would mean everybody in Chicago got murdered. That would be terrible. I don't think that any city is going to be that high, right? So I suppose somewhere out there, there's probably a town that had 1 person, and if he got killed, then it had a murder rate of 1. But short of that, yeah, it's going to be a tiny number. So typically what we do, there's nothing wrong with that tiny number, but people just don't naturally work very well with tiny numbers. And so usually what we do is multiply the result by 100,000. Okay. And that gives us the number of murders per 100,000 people in the city. So there were 17 murders per 100,000 people. If you were a resident of Chicago, your chances of being murdered were 17 in 100,000. That doesn't sound so bad, does it? You probably do a lot of things riskier than that on a day-to-day basis. Anyway, let's fill this down for all of the other cities in the spreadsheet, which we can easily do just by double-clicking on the little nib in the lower right-hand corner. That will send it down, and as it sends it down, it will adjust the row reference by 1 for each new row, so that we're always ensuring that we're calculating the murder rate for that particular city. Now if we sort in descending order, what city in the country had the highest murder rate? Well, Baltimore City Sheriff shows up number 1, but it's not because of that. It's just there's an error in the formula since it reported no data. It always reports no data every single year. I don't know why they're ever there. I'm just going to delete them. Okay, Industry, California ends up being the city with the highest murder rate. They had a population of 254, and 4 people were murdered in that city, giving us a murder rate of 1,574 per 100,000. Now, I'll bet you've never heard of Industry, California, and you probably haven't seen it in the news as having the highest murder rate. Nor have you probably heard of Gant, Alabama, where 1 person was murdered, but the population was only 204. Right? So, whenever you do these calculations, the top cities are going to be the ones, for murder especially, will be these tiny towns where 1 murder just happened to occur, or 2 or 3, and therefore, for that year, they end up having an extremely high rate. Industry has some other things going on too. Its population is only 254, but like 50,000 people work in the city during the day, and that is one of the pitfalls. We'll talk more about this, but one of the pitfalls of calculating rates based on residential population, it doesn't account for all the visitors, all the daytime workers, everybody else who might be in a city during, on a day-to-day basis. There are some cities, when you do these calculations, they get, sort of screwed because they don't have much of a daytime population, and they have a lot of visitors. For instance, if we did theft, for years, Myrtle Beach, South Carolina came up as number 1 for theft. I don't know if they would now, but let's find out. Theft rate. We'll take the theft total, K2, divide by the population, multiply by 100,000. So, yeah, Industry, California had more thefts than people. Again, because it's just a highly industrialized, lots of workers. Lakeside, Colorado ends up coming up number 1. So they had 140 thefts for only 16 people that lived there. But again, this is a situation where the residential population is virtually nothing, but there's a major shopping mall and a lot of retail going on there. So naturally, the residential population is kind of meaningless when it comes to calculating something like theft, which is very dependent upon residential, commercial property rather than residential property. Same problem with industry. Both Industry and Vernon, they're really close to each other, and they have the same issue with being industrial cities where there's a lot of workers during the day. Blackhawk, I think, has 128 people and a huge casino, so that explains that. With these small populations, the point is a lot of these cities get a little bit unfairly targeted. So using the tools that we introduced a couple of videos ago with filtering, I'm going to turn on my filters and say I only really care about cities with a population greater than 25,000. And now we see East Point, Georgia, has the highest murder rate if we're concerned with populations only of 25,000 or above. If we were concerned about populations only of 100,000 or above, Birmingham, Alabama would be the highest. How far do we have to go to find New York City? I guess it's just New York. Why is it not finding it? Oop, something has gone amiss with my sheet. Hang on, I'll be back when I fix it. Well, I had to completely redo it because I had to force Excel to quit. But anyway, New York City ends up being pretty low on the list at about 4 murders per 100,000 people, a lot lower than even the large cities that we find towards the top of the list. Again, we're only considering cities greater than 25,000. Right, so like Birmingham, Alabama had 59 murders per 100,000 people compared to New York's 4. Chicago, which is often described, in the news as being a terribly, terribly unsafe city with a high murder rate, I don't know. I can't see it on this list. Let's find it. Chicago Heights is higher. There it is at 17. So yeah, definitely worse than New York, but not really near the top of the list. What's the safest city when it comes to murder in the country? Well, that's going to be tough because a lot of cities had no murders. I suppose it would be the city with the highest population that has no murders. And that would be Overland Park, Kansas, the headquarters of the International Association of Crime Analysts, with almost 200,000 people and no murders. Okay, a couple of points about rates. So, the multiplication by 100,000, that's just convention. It really doesn't matter what we multiply by. We could have done 1,000, 10,000, a million, as long as we do the same for all states, for all cities rather, and then represent the results in terms of this is the number of murders per that many people, per 100,000 people, per million people, per 56,275 people. It doesn't matter, right? So the multiplier is just to get the number out of the decimals so that we can more easily talk about it. So, you do occasionally have problems where somebody who doesn't really understand statistics from East Point, Georgia would say, but we don't have 100,000 people. So why are you telling me we have 78 murders per 100,000 people? We only had 30 murders. Why are you making it worse than it is? And but statistically, the calculation makes sense. It's like you're saying, yes, but if you did have 100,000 people, then this is the number of murders you would have proportional to the number that you actually did have. It just allows us to be able to compare multiple places of varying populations. But if we wanted to, make somebody from East Point who still didn't get it feel better about the whole situation, we could make it 10,000 instead of 100,000. And as long as everybody's the same way, okay, now in East Point you've got about 8 murders per 10,000 people. You do have fewer than 10,000, so maybe that'll make you feel better about the way the calculations are done. The other thing that's important to understand about rates is, yes, you have to have a denominator that makes sense, right? So we've talked about this. Residential population is easy to find thanks to the U.S. Census Bureau for every city, but it's not necessarily the best way to calculate a city's crime rate. I think ideally what we would have is some sort of index of the total amount of activity in a city, not just the residential population, the number of visitors, the amount of commerce. I don't know how you'd calculate that, and it would be tough to get it for every city in the country, but it would be a more valid calculation than the residential population. Now, as another example, think about hotspots. So I have all these different parking lots in the area that I live in, different grocery store and department store parking lots, along with the number of, I think this was the total number of thefts from vehicles and vehicle thefts that occurred in those parking lots across a variety of years. They all fell a lot in 2020 to 2021 because that was COVID and people were going out less. But anyway, so let's say I want to normalize this, right? I want to calculate the rate of the thefts in these various parking lots, because if I showed this at some community meeting, somebody from Walmart might be there, and he might object quite reasonably that Walmart has the largest parking lot in the region. So there are more opportunities for theft in that parking lot. And therefore, it's saying they have the most dangerous parking lot is a little bit misleading. What if the Shaw's here, that's number 2, had only 10% of the number of spaces that the Walmart did? then the Shaw's would, on a per capita basis, would be more dangerous than the Walmart. So how do you figure out a rate for something like for something like these thefts? What you really want to know is how many people parked in these different parking lots during those years, or during this period. How many people parked there? Because that's how you determine how much risk there was, and then you can divide by the total number of thefts by the total number of people that parked there. But where are we going to get that kind of number, right? We can't. There's just no way we can figure out for all these parking lots how many people went and parked there. Actually, even the number of people that parked wouldn't really be perfect, because some of them might have only parked for a short time in some lots and a long time in other lots. We would want to be able to calculate the number of parking hours per parking lot during that period. And again, we don't have anything like that type of data. But what we could figure out is the number of parking spaces per in each of these lots, or we could calculate the square footage of parking in these lots. That neither would be perfect. Some of these lots might have a lot more spaces than ever get used. Others, would have a lot more physical space than ever gets used. But that would still be better than just counting them all equally, right? So sometimes the denominator that you use for ratios is not. It's the best you can get, I suppose, for what you're trying to do, right? So, and then I'll just randomize the rest. I don't know what they actually are. I actually had students go out and calculate these at one point, but I didn't save that. So then, anyway, we can take the total number of crimes, divide it by the number of parking spaces, and multiply it by something like 100. So we get the number of crimes per 100 parking spaces. And then if we sort by that, it turns out that this, again, don't take this. This is a real address. Please don't take this and tell anybody that Northern Light in Bangor has the biggest problem. I made up the number of parking spaces. But you get the idea. And the Walmart doesn't look quite so bad. I'm sorry, these look like they didn't sort in order because I didn't freeze the random calculations that I did there, so that it gave us new random numbers. So there, that's better. The Martins and Brewer, again, fake data, so don't go running out saying that's the worst place. But if this was a real life scenario, we would want to then maybe concentrate more problem solving resources on the Martins. Now that doesn't mean, for like directed patrols, we would spend more time there. They only had 65 thefts across 5 years. So the average of the likelihood an officer is going to encounter somebody on a particular night is pretty low. We might suggest they put up more lighting or something like that, but if we were going to just put an officer where he could catch somebody breaking into cars, we'd go where the highest volume is, not necessarily the highest rate. So you're not always necessarily using rates. But that's how to calculate them in any event. Moving on, we're going to look at central tendency and variance in the context of a common technique called threshold analysis. And if you're taking one of my crime analysis courses, this will become important in a few weeks when we talk about tactical crime analysis. So, with threshold analysis, we're trying to determine how we're doing in a particular time period, say 2025, how we're doing this year compared to previous years. Now, it's important to understand that in doing these calculations, we're not necessarily working with the entire year. As I record this, 2025 isn't even over yet. So if this is an example I'm using for the current year, obviously I'm not going to compare all of 2025 when we only have 8 months of it to the entire year of previous years. 2025 would look great compared to those years. I might do year to date, so I might calculate these statistics. This is an aggregation, of course, right? So I could have gotten this out of a pivot table in which I looked at only January through July of these previous years. Okay, so those aren't whole years; these are just January through July, or they might just be the last 2 weeks or the last month. The specific time period doesn't matter as long as it's the same for all of the previous years. We want to compare apples to apples. When we ask how we're doing in August 2025, we don't want to compare it to July and June and May and April of 2025. because places have seasonal variances in crime, and so you're not doing an apples to apples comparison. If I want to ask how am I doing in August of 2025, I want to compare it to August of 2024, August of 2023, August of 2022, etc. Okay. All right. So let's say that's the question we're trying to ask, regardless of what the time period is. By the way, geography doesn't matter either. We could do it for the entire city. We could do it for one beat. We could do it for one street. Right. But for this scenario, we'll assume we're doing it for the whole city. How are we doing in 2025 compared to these previous years? As you saw with the Chicago Police Department, a lot of places do it simply based on the percentage change from the previous year. Let's see how to do that calculation. That is simply going to take the 2025 figure, subtract the 2024 figure, and divide by the 2024 figure. That's how you do percentage change. It's new minus old divided by old. Okay, and we have to do this part in parentheses. We have to do that first, because the order of operations would normally do the division before the subtraction. So we're going to take H2 minus G2 divided by G2 and fill that down. And then that's the proportional change. To turn it to a percentage, we just simply have to hit the percentage symbol on the Excel toolbar up here. So, abandoned motor vehicles went up 47% between 2024 and 2025. Aggravated assault went up 60% between 2024 and 2025. That sounds pretty bad. But let's take a look at the historical data for aggravated assault. 11, 11, 5, 14, 6, 5, 8. So the 5 that we had in 2024 had happened before in 2021, but still that's the lowest number we ever had. So and then it kind of just regressed to the mean from there. In fact, I bet 8 is really close to the average. When you look at that historical data, does 8 really seem all that out of place? Does 8 really stand out? Does 8 make you think that that's something you want to go to the chief and say, Chief, we have a 60% increase in aggravated assault? Yes, we do from the previous year, but looking at the historical data, 8 really is kind of normal, right? So that's why I don't ever recommend actually doing changes from just one year to the next. A lot of police departments do it, but what's so special about 2024? Why are we going to regard that as our baseline? Right? It could have been unusually low for a variety of reasons. It could have been unusually high for a variety of reasons. And so regarding it as the only method of comparison in 2025 seems silly. What I'm going to do instead is calculate an average. So let's get rid of this change column. I want to calculate an average of these previous years and then compare 2025 to that. Let's compare it to what's normal compared to what's usual. So I'm going to insert a column here between G and H. Actually, let's just go ahead and do 3 columns while we're at it. And the first one will be the average. Let's title it mean. That makes it a little bit more precise. The arithmetic mean is calculated by simply adding up the observations and dividing by the total number of observations. So we take the sum of all of this, which is 109, and divide by 6 to get, and Excel's already telling us the average is about 18 for abandoned motor vehicles. Now in Excel, you can just do that with the average function. It ought to be the mean function, but for whatever reason, that's what they chose to title it. So we say equals average, open parentheses, B2 to G2, close parentheses. Fill that down. And now we've calculated the mean for each crime here, or they're not just crimes, some are other types of calls for service, over the previous 6 years. Now, we could compare, I think it would be entirely valid to compare 2025 to that. Oops. Why am I not seeing row 2? There we go. It would be entirely valid to compare K2 minus the mean, H2, and divide by H2. And to say we had a 21% increase in abandoned motor vehicles from the average. But now look at the different story with aggravated assault. As I said, the mean for aggravated assault is right about 8.7, and so our change in 2025 is actually an 8% decrease, not a 60% increase if we're looking at the historical data. So that's how you do percentage change, whether it's a single year or from the average. But percentage change is, even though it's very commonly used, really you can't attach any level of statistical significance to it. What is a significant percentage? 25%? Anything that's double digits, right? With crimes that have very small numbers, like arson, it's easy to have 100, 200, 300% increases or 100% decreases. Decreases can never be more than 100%. Increases obviously can be much higher if they double or triple or quadruple, but 100% decrease means you lost all of them. So in any event, the numbers can be really, really high. The percentage can be really, really high when the numbers are quite small. Conversely, when the numbers are quite large, the percentage change can be small but still meaningful. So if you looked at all calls for service, for instance, which would be in the tens of thousands, and you had a 5% decrease, that might be really significant. So you have to always think about the change in terms of the total number. That can be kind of exhausting and difficult. So I'm going to introduce some alternate calculations that tell us how things are in 2025 that don't rely on percentage change, that are a little bit more meaningful. The first one is called the standard deviation. And it is calculated, I don't know why this keeps happening, there we go. It's calculated by using the formula STDEV dot P and then specifying the range that you want to calculate. And then filling that down. So the standard deviation, what is that? Well, as you can see, let's take one that has an precise mean here. Employee theft. The mean is exactly 5. And in one previous year, there was exactly 5 employee thefts. But every other year deviated from that mean by some amount. So the year that there were 3 employee thefts, that deviated from the mean by 2. And the year that there were 8 employee thefts, that deviated from the mean by 3. The year that there were exactly 5, it deviated from the mean by 0. So what the standard deviation tells you is, in any given year, what's the typical amount of deviation from the mean on either side? And this calculation gave us 2, a little over 2. So subtract 2 from 5 and you get 3. Add 2 to 5 and you get 7. And it's telling us in the typical year you'd expect like 3 to 7. Yeah, we had 8 a couple of years. But most years, in 4 out of the 6 years here, it fell within 1 standard deviation of that mean. And that's in fact exactly the percentage of the time we would expect it to fall within 1 standard deviation of the mean. We would expect it to fall within 2 standard deviations of the mean about 95% of the time. You can't get that with only 6 observations, but basically all of them should fall within 2 standard deviations. So again, it's technically over 2, but let's just say we multiply it by 2. We get 4, right? So 2 standard deviations is 4. Subtract that from the mean of 5, you get 1. Add it to the mean of 5, you get 9. 1 to 9. Do all of our employee thefts fall within 1 to 9? Yes, they do. There will be some exceptions for extreme outliers, but generally speaking, 2 standard deviations will give us all of the data in the observed years here. Actually, I'm not going to use this column. We're just going to do mean and standard deviation. So, what we're going to do over here in column L is calculate not the X, sorry, the Z-score, as it's called, which tells us how does 2025 compare to the mean, not in terms of the mean, as we do with percentage change, but in terms of the standard deviations. How many standard deviations from the mean is 2025? And we calculate that by taking the 2025 figure with an open parenthesis, subtracting the mean, and dividing by the standard deviation. And then filling that down. So, remember the windows that I was talking about, right? So let's do another one. Again, it's easiest if it's something where it's an exact mean. Okay, thefts from persons. Mean of 9, standard deviation of 2.7. Let's make it 3. So 9 minus 3 is 6, right? 9 plus 3 is 12. So that's a 1 standard deviation window. So if the 2025 figure it was 6, the z-score, remember it's not perfect because it's not technically 3, it's 2.76, but the z-score is really close to negative 1. If it was 12, the z-score is really close to positive 1, right? If we were doing a 2 standard deviation window, 9 minus 6, because that's going to be 3 multiplied twice, is going to be 3. And on the high end, it'll be 15. Okay. So again, if the 2025 figure was 15, that would tell us we're 2 standard deviations above the mean. Okay. And slightly outside of the normal window. So, most of the time, we would expect this z-score to be between negative 1 and positive 1. Almost all the time, we would expect it to be between negative 2 and positive 2. If it's below negative 2 or above positive 2, something really unusual is happening to this crime. So if I sort it in descending order, we see that OUI, operating under the influence, is way outside its normal range. It's got a mean of 17, a standard deviation of 4, and the number of 31 that we have in 2025 is 3.3 standard deviations above the mean. What happened? Why is it so high? Are a lot more people drunk driving? I mean, in real life, if I was interpreting this, that probably means that we did some sort of special extra enforcement for OUI. We made more arrests and therefore caught more people, and that's why the numbers are so high. Not so much there was more drunk driving, but I could be wrong. Why is trespassing so up? We'd have to go look at the data. We'd have to do more analysis on these categories. But this system helps us determine what we need to focus on. Sometimes it's a sign of a serial offender who's come to town that causes numbers to go so high. And so we often use these calculations in tactical analysis when our time periods for these past years and the current year aren't the entire year, but just the past month or the past 2 weeks. And we do these calculations, and the z-score helps us determine which crimes we need to take a closer look at qualitatively by reading the narratives and trying to identify, is there any pattern going on here? But on a long-term basis, so if we were looking at year-to-date statistics, these calculations would just help us determine how we're doing, with the z-score being much more useful for that interpretation than the percentage change, although more difficult to explain to an audience. So analysts use a variety of techniques for that I'm not going to get into right now because we just need to focus really on the calculations. All right, we're going to move on now to correlation, which shows us the relationship between variables, and specifically between ordinal or interval variables. So if you go to the tab now, it's blank. We're gonna populate this with some material from over here on the UCR 2024 page. So if you've got any filters turned on, go ahead and turn them off. And let's calculate, not next to the murder rate, let's calculate the overall violent crime rate. Violent rate. And again, for that, we're going to take the violent crime total, D2, divided by the population in C2 times 100,000. And fill that down. All right. So I want to ask the question, is the violent crime rate correlated with the poverty rate? Is there a correlation, a relationship between poverty and violent crime? And in order to do that, I'm going to need to collect the poverty rate for a number of cities. Now, I'm certainly not going to do it for every city on this list. I could probably find it, to be honest. I mean, I could download a census data set, I suppose, that has the poverty rate and join these two tables in Access and literally do it for every single city on the list. But we're gonna simulate a research project here and assume that we don't have time to do that. So we are going to do instead is just look up a sample. We're gonna get a sample of the cities here, and we're going to look up the poverty rate for just that sample, and then do the correlation on the sample, and assume that because we're going to do a random sample, we'll assume that it's we can generalize it to the nation at large. Now we want to do multiple random samples, in a real study like this, but we are about to do multiple random samples because everyone doing watching this video and doing it for themselves is going to have a different selection of cities to study. So, I don't know how I got murder rate in there instead of murder. So what I'm going to ask you to do in column P is to title this RAND, and then in the actual cell here, we're going to use the RAND function, R-A-N-D, open and close parentheses right after it. The RAND function generates a random number between 0 and 1, and it doesn't have any arguments, so there's nothing to put inside the parentheses, but you still need them because it's a function. So type that in, and then that'll give. Now you won't have the same number that I do, right? So understand that, but fill that down, and notice it changes every time you do anything on the sheet. And having filled that down, sort your sheet from on the data ribbon here. We're going to sort our sheet in either ascending or descending order. It really doesn't matter which one. Either way, it's just going to give us a random order of the cities. Okay. So I got Gastonia, North Carolina on number 1, but you're going to have something different. That's fine. That's what I want. That's by design. Okay. So we're not going to care about these cities with very low populations, and we're going to have a hard time finding the poverty rate for them anyway. So let's just do it for cities that have at least 100,000 residents. So what we're going to do is turn our filters on the data ribbon, and for the population, we're going to say we only care if it's greater than 100,000. Okay, so I've got this list. What I want you to do is select the top row and the first, say 15 rows beneath it. I think I went maybe over by 1, but it doesn't matter. More is okay. You don't want to do less, but more is okay. So select the first 15 rows. More if you're willing to do more, but we're going to have to. I'm going to be asking you to individually look up the poverty rates for these cities. So 15 is probably the most that it's fair to ask you to do. We're going to copy, so I just hit Control-C while those cities were selected, and then I'm going to go to the Corel tab here and paste. And I wanted to copy out my selection so it doesn't get confused with any other data. So this is my sample of cities that I'm going to figure out the poverty rate for. Now the poverty rate can be determined, you can do it a couple of ways actually. So let's add a field here for poverty. Poverty, I couldn't spell it. We could type in the percentage of citizens living at or below the poverty line, which is what most people usually mean by the poverty rate, or we could put in the mean or median income for the city. So there's a couple ways you can measure economics. You might be curious about a similar calculation. Maybe poverty isn't exactly what you're interested in, but you want to look at the tax rate of the city, or the city budget, or the population density, or I'm trying to think of any other demographics that would be easy to obtain. The percentage of citizens under the age of 18. I encourage you, if you're doing this as an assignment for me, you do not have to use poverty. As long as you can find the statistic for any city, then you can try something else, so that we have get some slightly different answers here. So we have to look up the statistic for each of the cities on our list, and probably the easiest way to do it is simply to use Wikipedia. I could ask you to go to the Census Bureau and do it there, but it might actually be slower than simply using Wikipedia. So this is what you need to do. And Wikipedia, I know it has its issues, and as a professor, I probably should not recommend it, but it's usually pretty reliable for things like this. There we go. Freeze panes. Okay. So what I'm going to do is go and look at Wikipedia for High Point, North Carolina. And search for poverty. And almost any city's Wikipedia page is going to mention in there, well, of course, this one doesn't though. So it was 13.2% in 2000. Okay, well, I'm going to have to look at more recent figures for High Point, North Carolina. Most of the time, though, you should find a discussion of the most recent census. You might have to go to other sources. If you just Google so the Google's AI overview these days will probably give you the more recent statistic. Okay, and here's a similar statistic from the first result, 14.7, 14.69. So that these all seem to agree. So maybe Googling is a better way to do it, and just keep replacing the city. Either way, you're going to type the result in here. Remember, 14.69%. I mean, I guess it doesn't matter whether I represent it as a percent or a proportion, but the statistician in me wants to do it this way. You could do it either way, though, as long as you're consistent with all of them. So look up the statistic, whatever you're looking up, for all 15 of your cities, and then resume the video. All right, I am back. So I've figured out the poverty rate for each of the cities in my random sample. Hopefully you have done the same. At the bottom, we're going to type Corel for correlation, and we're going to figure out what is the relationship between these numeric variables. Now we could do it with a graph. We could select the violent crime rate and the poverty rate. I'm using the control key to select multiple non-contiguous or we could just get rid of the rand column. We don't need that anymore. And then just select them there. Okay, and then we could do a scatter plot. And a scatter plot shows us graphically the relationship between the variables. And if you look at a scatter plot and you can kind of figure out how you would draw a line through it, then that's a sign that they are in fact correlated. If the dots are all just kind of in a lump or a ball, then that's a good sign that they are not very, very correlated. So let's calculate the actual specific correlation down here. And that's done with a function. I'll zoom in a bit here. That's done with a function called correl, C-O-R-R-E-L. You open the parentheses and you choose, too far there. You choose the range, the first range of statistics that you have. So I'm going to do 02 to 017. And then a comma, and then the second range, P2 to P17. So I end up doing 16 here. And we get, in my case, a correlation of 0.68. Now, correlation works on a scale of -1 to +1. So if we got a perfect +1, that would mean that not only are they correlated, they are so correlated that you can perfectly predict one based on the other. If you know a city's poverty rate, you can tell its violent crime rate down to the exact figure. Obviously, if we actually got that in real life, we would have to be suspicious of the data set, right? Because nothing is ever quite that perfect. There's always a little bit of variance. A -1 correlation, which mean the same thing, would mean that it's perfectly predictable, but in a different direction. Now, in this case, it would mean that the more poverty, the lower the violent crime. Now, that would go against our experience in this country. If we knew nothing about criminology and we were trying to explain why that might happen, we might be able to come up with something. We could say, well, people who are poor have to work multiple jobs, so they don't have time to get into fights or, abuse their spouses or anything, right? Something like that. But again, it goes against our experience to have a negative correlation between violent crime and poverty. But you might have gotten a negative correlation if you, instead of poverty, did income. Because obviously poverty is the opposite of income, right? As income rises, poverty falls, and you would expect, therefore, a violent crime rate to fall. So if you did income instead of poverty, you might have gotten a negative correlation. So 1 is the highest it ever goes, -1 is the lowest it ever goes. 0 in the middle means there really is no correlation at all, no relationship between the variables. 0.68 is pretty high. It's a relatively high positive correlation, and it indicates that there really is a relationship between the two variables. Now, it just tells you there's a relationship. It doesn't tell you the directionality of that relationship. So we don't know whether violent crime creates poverty or poverty creates violent crime, or maybe they kind of have a mutually reinforcing relationship, or maybe they're both caused by a third variable that we're not considering here. So we have to... That requires a lot more research, trying to determine what is actually the relationship in the variables here. And it's bad science to see a correlation and assume causation. But there is definitely a relationship. And there are a couple outliers here. There's a city here. Let's see, which one is that? 302 for its violent crime. Oh, that's Ann Arbor, Michigan. So Ann Arbor, Michigan has a pretty high poverty rate. One of the highest. The highest. No, not the highest. Baltimore had. But the second highest in the sample that I took. And yet its violent crime rate is not very high in response. And notably, it had no murders in 2024. Not a lot of outliers on the other side, so we don't see a lot of cases in which there's a low poverty rate and yet a high violent crime rate. But overall, this does indicate a high correlation. So what is the correlation that you're getting for your numbers? Now, if you did poverty, it probably is close to this. I would say, I would guess maybe you got a number somewhere between 0.45 and zero point 0.8 or something like that. But it might not have been. Maybe you just got a weird sample, or maybe I got a weird sample, and all of you came up with something different. So we always want to compare multiple samples, and obviously the more data points we add to this, the more that we can reform or refine this particular number. So here we are at 0.68. All right, now I've got 5 more cities, and I'll adjust my range here to account for them. And now I'm down to 0.6. So I ended up with a lower correlation by adding those additional 5 cities. I think partly because I had another another outlier here in Boulder, Colorado, which has a relatively high poverty rate and yet a low crime rate, although Newport News, Virginia, has a violent crime rate that's more than I would expect based on the poverty rate. Actually, so does San Francisco. San Francisco, has a decent amount of crime, but you can't really be poor and live there. But the point is, generally speaking, the more cities, the more observations you add to your sample, the more the number is going to reflect the actual population. And it might be the reality that, in fact, poverty and violent crime are more variable than my initial selection of cities suggested. So that's how you do a correlation, and that's how you interpret correlation. Finish it off for your cities, for your whatever statistic you decided to calculate, and then we'll move on to the final tab. All right, we're going to finish here by looking at simple linear regression. Regression builds upon correlation by helping us determine basically what the value we should expect to find for for one data set given an input from another data set. So if we go back to my graph here for between poverty and violent crime, and I added a trend line to it. Again, this is basic linear correlation, so I added a linear trend line. So we had all these samples, and we might ask ourselves, what if we knew a city had a violent crime rate of about 1,500? What would we expect its poverty rate to be? And I go up here, and I look at the trend line, and I say at 1,500 for the violent crime rate, we would expect the poverty rate to be just over 20%. Or we might say, hey, we know a city has a poverty rate of exactly 10%. Well, in this case, it's going to give us an odd result. What would we expect its violent crime rate to be? And we would say with a poverty rate of only 10%, at least on the trend line, we would expect its violent crime rate to be pretty close to 0. Now, obviously, there's some variance on both sides of the trend line, and quite a bit of it. So, that 10% here, based on the amount of variance, just visually interpreting it, could translate to a violent crime rate of anywhere between like 0 and 250. But that's basically what you're trying to do. You're trying to determine, given the trend line, where we would expect a particular value to fall. Now we're going to do this with years and calls for service. And just so we can see it graphically, you don't have to do this. I'm going to put a graph. Stop it. Actually, I'll do a column graph. Okay. And we can see that this is a city whose calls for service have been steadily increasing over this time period. Not always. There are a couple of years it went back a little bit, but generally speaking, it's been going up, as a trend line will demonstrate. And we can even forecast the trend line forward a couple of periods. So we can ask a question like, where would we expect to be in 2026 if these are the calls for service we've had through 2025? Now, what is being correlated here? It's the year and the number of calls for service. And if we do a quick correlation on it, we find a very, very high positive correlation. You can almost entirely predict the number of calls based on the year, or conversely, if we knew how many calls we had, tell you what year that it most likely was from. But it's kind of silly to say the year is somehow causing the number of calls for service, right? Like the people in the community aren't saying, "Oh, it's 2026. I guess we better call the police more often than we did last year." Especially since 2026 is a higher number than 2025. I mean, there's nothing about these numbers. These numbers are almost nominal data in a way. They're labels, right? Why would a label like, today, this year is 2026, cause an increase in calls for service? But of course, that's not what's happening. There's a relationship, sure, but the year isn't the cause, nor is the number of calls the cause of the year. Something else, like increases in the population over those years, or development of the city over those years, is causing the change in calls for service. But when you have a correlation, it doesn't matter if one is causing the other. If it's predictable, if it has a correlation that high, then you can use it in your analysis, regardless of whether it makes logical sense. So, in 2026, we want to know, where is this headed? How many calls for service should we expect to have in 2026 based on the number that we had, the numbers that we've had over the years? And the formula for this, which I'm going to enter all in one go here, but the formula for it is the slope times the x variable plus the y-intercept. Now, the y and the x variables, again, are the x is usually described as the independent variable, the variable that is just doing its thing and isn't being influenced by the other one. The y variable is the one that's being influenced. So in this case, it would be ridiculous to think that if the call for service total next year was different, next year wouldn't be 2026. It would be some other year, right? So obviously the call for service total is not influencing the year. It's the year that's influencing the call for service total, even though that influence isn't, it's not, influencing is the wrong way to say it. It's the year that's independent. The year is just going to keep on marching on no matter what happens. It's the call for service that is following the changes from year to year. So the call for service is the y variable. So what we do have to do is calculate the slope that indicates how much this trend line is going up, basically, times the x variable, the year, and then add to it the y-intercept, which is where this trend line is going to hit this axis. For some reason, mathematicians have long represented the slope using the I'm sorry, I don't know why it says m, x. The slope using the symbol m, and the y-intercept as b. That's why I typed b there. So equals mx plus b, or y equals mx plus b, is the way that this is often presented to students who are taking this in high school. So if that just caused a flashback to high school math, that's why. So down here in 2026, that's the y variable, and we're going to say that equals the slope of the data set. And here, unlike correlation, the order matters. So we have to do the y's first. B3 to B18. A3 to A18 is the x variable. times the x variable that we're trying to predict, 2026, plus the intercept. And again, it's the same range, B3 to B18, comma, A3 colon A18. So we could have calculated each of those things separately and then to put them all together, but I decided, what the hell, let's do it in a single formula. And when we're done, the best prediction, therefore, that we have for the number of calls for service that we're going to have in 2026 is 100,745. Now, you might object to that thinking, hey, that's less than 2025. Haven't these numbers been going up? And the truth is they have, but what happened was in 2025, you can see that the total was a bit higher than the trend line would have predicted. And that's happened before. Like in 2015, it was a bit higher, and the 2016 figure, which was right on the trend line, was a bit lower. So we're saying the trend line predicts that would happen again. Now, there is some variability. And if you're really curious, the variability is called the standard error. And you can calculate that with, you don't need to do this if you're doing an assignment for me. For those of you who want to know. So that indicates how much variability there is around the trend line, basically. And then if we were to take the predicted figure here and subtract that standard error divided by 2, and then take the predicted figure and add the standard error divided by 2, we would get a range that we would expect the 2026 figure to be. But even the highest end of that range is lower than the 2025 figure. So this particular set of calculations is predicting that 2025 was unusually high, and it's going to fall a bit in 2026, yet it will still be consistent with the upward swing in the trend line overall. So that is how we do regression analysis. You simply, basic linear regression is to calculate the slope of the trend line, where it intercepts the axis, and then with those calculations, you can predict for any x the value of any y. Now, a tactical example of these calculations we've been doing would be found in something like a bank robbery series, where the dollar value stolen is correlated with how long the offender is waiting between his robberies. So here we found a 0.885 correlation between the dollar value stolen and the interval between offenses, and then using linear regression analysis, we would predict a range of between October 8th and October 16th for the next incident based on the $6,000 he stole in the most recent incident. So there's a lot of applications for these different calculations in crime analysis. So if you're doing this assignment for my class, what I'd like you to have is something in each of these tabs that, where you finish off the calculations that we've been doing, rates, and you can practice with other crimes. It doesn't have to be murder or violent crime. You could try something else. But rates here in the UCR tab, finish the threshold analysis, how I did it, in the threshold tab. Right? Your correlation tab will have different cities and may have a different variable that you're looking at. But you should have a final correlation calculation at the bottom, and then your regression tab should simply replicate the formula that I did here. But turn in all of that to show me that you walked through this and that you understood what you were doing, because these calculations are going to become important when you do the tactical and strategic analysis assignments later in this course. Now, if you ran into problems and you need some help and you're in one of my courses, there ought to be some help sessions available for you. But otherwise, you're welcome to reach out to me at this email address and telephone number, and I would be glad to answer any questions. I hope this has given you a window into the most common types of quantitative analysis calculations that you will see in crime analysis. And we will be doing a similar video on qualitative analysis techniques later on. Thank you very much, and have a great day.